All right, let's dive right in. Over the next few minutes, we're going to break down one of the most fundamental concepts in all of modern networking: virtual local area networks, or VLANs. These are basically the invisible walls that keep our digital world organized, efficient, and most importantly, secure. So let's get to it.
So picture this. You're running the network for a company. You've got one single physical network infrastructure. But you have a problem. The engineering team is working on top-secret projects, and you absolutely cannot have the marketing team, or anyone else for that matter, seeing their data. How do you do it? How do you keep them totally separate without having to build a whole second, expensive physical network from scratch?
Well, the answer, my friends, is the VLAN. It is such an elegant solution. A VLAN lets you create multiple, separate, logical networks that all live on top of your one physical network. You can think of it like putting up digital walls inside your building. The devices in one VLAN can't see or talk to devices in another, even if they're literally plugged into the same exact switch. It's all about creating that logical separation right there at layer 2.
So, why do we bother with all this? Well, the benefits are huge. First and foremost, security. It's the big one. Isolating groups of users means you can tightly control who has access to what. Second, you get way better performance. By chopping up your network into smaller broadcast domains, you cut down on all that noisy background traffic that can really slow things down. Third, it just makes management so much easier. You can group people by their job, all the sales folks in one VLAN, HR in another, no matter where their desks are. And finally, it saves a ton of money. No need to buy extra switches or run a whole new set of cables. It's just a brilliant, brilliant tool.
Okay, so how does this magic actually happen? How do the switches make this work? Well, it all comes down to how we configure the ports on our switches. And there are really two fundamental types we need to understand.
Let's break them down. On one side, you've got the access port. Think of this as your standard everyday port. It belongs to one and only one VLAN. This is where you plug in your end devices, your PC, your IP phone, a printer, that kind of thing. But on the other side, we have the trunk port. Now this is the superhighway. A trunk port is special because it's designed to carry traffic from multiple VLANs all at the same time. This is how we connect switches to each other, so someone from marketing on the second floor can still be in the same VLAN as their colleague way up on the 10th floor.
Okay, that leads to a pretty obvious question, right? If a trunk port is this big highway carrying traffic for a whole bunch of different VLANs, how does the switch on the other end know which data belongs to which department? It's got to have some kind of system, a set of rules for the road. And that system is called 802.1q tagging. This is the universal standard that basically all modern network gear uses. It's pretty simple, actually. When a frame of data is about to leave a switch on a trunk port, the switch sticks a tiny digital tag onto it. This tag is just a number that says, hey, I belong to VLAN 10 or I belong to VLAN 20. The next switch sees that tag, reads it, and knows exactly where that frame needs to go. It's really just like putting a mailing label on a package. But in networking, for every rule, there's always an exception. And in the world of VLANs, that exception is called the native VLAN. Traffic that belongs to this one specific VLAN is allowed to travel across a trunk link without any tag at all. Now, by default, on pretty much every switch out there, this is VLAN 1. And this little detail is so important because if you get it wrong, if it's misconfigured, it can open up some major headaches and even some serious security holes. So, we've had enough theory. Let's make this stuff real. What does it actually look like when you sit down at a keyboard and tell a switch what to do? You might be surprised how straightforward the basic commands really are.
Let's take a look at a typical Cisco switch. Setting up a basic access port is really just a simple three-step process. First, you tell the switch which port you want to configure. Here, it's interface Ethernet 0/0. Second, you tell it what kind of port it is, so you say switch port mode access. And third, you assign it to a VLAN. Here we're saying switch port access VLAN 10. That's it. That port is now officially a member of VLAN 10, and only VLAN 10.
But of course, in the real world, things aren't always configured so perfectly. And that brings us to one of the most common and frustrating issues that network engineers have to deal with: the native VLAN mismatch.
So here's the deal. When you connect two switches together with a trunk link, they absolutely must agree on which VLAN is the native VLAN. If switch A thinks it's VLAN 99, but switch B thinks it's the default, VLAN 1, well, you've got a mismatch, and the consequences are no joke. We're talking about data getting sent to the completely wrong place, connections that drop in and out randomly, and even security flaws that clever attackers can use to hop from one VLAN to another. It's bad news.
And how does this happen? Well, almost every single time it comes down to human error.
A simple typo when you're typing in the commands. That's a classic. Or maybe an engineer decides to change the native VLAN for security reasons, which is a good practice, but they only do it on one side of the link. We've all seen someone copy-paste the config from a template without double-checking it first, and that can cause it too. These little mistakes can end up causing some really big problems.
All right, so we've gone from the big picture concept all the way down into the nitty-gritty configuration details. Now let's tie it all together and see how this all applies to the actual physical hardware that makes our networks tick.
So here we're looking at a lineup of Cisco's Catalyst 9000 series switches. You see these things everywhere in the enterprise world. And notice how they're built for different jobs. You've got the 9200 and 9300 series, which are typically used at the access layer. That's where you plug in your computer. Then you move up to the bigger, more powerful switches, like the 9400s and 9600s. These are the beasts that run the core of the network, the super fast backbone. But here's the thing they all have in common. From the smallest branch office switch to the massive data center core, they all rely fundamentally on VLANs to organize, secure, and manage all that network traffic.
And that really brings us to our final thought for today. For decades, mastering VLANs has been a critical skill, a real badge of honor for any network engineer. But as we move into this new world of software-defined networking and intelligent automation, a really interesting question comes up. Will the days of manually configuring access ports and trunks and native VLANs, will those days become a thing of the past? It's definitely something to think about, as this foundational technology just continues to evolve.